Alrighty, rolling right into our second lesson for this topic. Well, second online lesson. This is our fifth lesson overall on outcome one. It has to do with unit rates, and what unit rates are used for really. I use them all the time when I'm in the grocery store because it's the way you figure out what's actually the best price. If you got the big bottle of ketchup and the small bottle of ketchup, which one's more worth your money? So to get you in the right mindset, I just want you to think about this problem here. The 2-liter bottle of pop costs $3. The 500 milliliter individual serving costs $1. And which one do you think is the better purchase and why? And so just by amount, 500 milliliters, that's half a liter. So I would have to buy 4 of those to get 2 liters. 4 half liters is 2 full liters. And if I buy 4 of those, I'm paying $4. So to get the same amount of pop, I have to spend $1 more than the 2-liter bottle. So the big one is technically the better buy. Now, often what I think about is why do people buy the small bottle then? And well, one reason is the small bottles are often in a fridge cold at the store, so they're ready to be drank right away, where the 2-liter bottle, you'd have to take it home and put it in your fridge and wait for it to be cold. The other reason, obviously, despite what many my grade 9 students think, the 2-liter bottle of pop is not a single serving of pop. You're not supposed to walk around with that and drink out of it directly, although I see lots of people in your age group do that anyway, and I'm sure I probably would have at your age too. But the 500 milliliter, if you just want a single serving, it's more closer to what a single serving of pop would be. So if you're just buying pop for yourself, you might just want to spend the $1 instead of the $3. But mathematically speaking, the 2-liter bottle is the best buy. You get the more Sprite for the same or for less money. So when we are looking for the better buy, we want to calculate what's called the unit rate. And the unit rate is the cost of one thing usually. So 6 bananas for $4.75, 5 bananas for $4.50, 7 bananas for $5.25. You want to get the cost per banana. So the cost per banana, and I like to write out what we're trying to get because that shows you the order that you have to divide. If you want the cost per banana, you have to do cost divided by bananas. So for Sobeys, I would do $4.75 divided by 6. For Zayres, I would do $4.50 divided by 5. And for Metro, I would do $5.25 divided by 7. And that would show me which one has the best cost per banana. So that works out to 79 cents per banana. This one's 90 cents per banana. And then 5.25 divided by 7. I think this one's the best. Oh, 75 cents. Per banana. So, based on that, this one's the best buy. And that would be Metro's cost is the best. You get cheaper bananas at Metro. So, for this one, which car has the better fuel efficiency, show your work. So the RAV4, 650 kilometers for 60 liters. This one's 64 liters for 680 kilometers, the Nissan Rogue. So, again, we want liters per kilometer. How many liters do we use to drive 1 kilometer? That's what we want to figure out. So if that's what we want to figure out, we're going to do the liters divided by the kilometers. So 60 divided by 650, and I get 0.092, I'll say something like that. Now, that's the liters per kilometer. Now that's not necessarily the best measure or the measure that you're going to see in a car commercial. So because it takes, you know, barely any gas to go 1 kilometer. 1 kilometer is not very far at all. It's like school to McDonald's or something like that would be about a kilometer. So you're not using a noticeable amount of gas to go that far. So the car commercials, at least in Canada, won't do liters per kilometer. They actually do liters per 100 kilometers, or liters per 100 kilometers is how it's often written like that. So in order to do something like that, when the unit's something really small like this and we get this weird decimal answer, they often change it to liters instead of just for 1 for 100. All you do is liters per kilometer, and then you times that answer by 100. So I'm going to take my answer times by 100 and get 9.2 liters per 100 kilometers. And that's how they'll show you fuel economy in metric in Canada. In the States, they'd actually do it the other way. They would do how many miles do you get in 1 gallon of gas with their imperial system, and they would do the MPG, and that is what is called miles per gallon, you might see. And they would take how many miles and divide by the amount of gallons to get that. But in Canada, we do liters per 100 kilometers, so you do liters divided by kilometers times 100. So liters divided by kilometers times 100. And this one's 9.4 liters per 100 kilometers. Now we want the better fuel efficiency. You got to think about what these units are telling you. And so we have to decide which one is the best, gets the best use of its gas. And it's the RAV4 because it uses less liters of gas to go 100 kilometers. So you actually want the smaller number here. Whereas if you were looking at the American measurement, the miles per gallon, if it's the other way, if the number is how many miles you're getting, you'd want a big number of miles for 1 gallon of gas. With this measurement, you got to think about what your units are. You want a small amount of liters to go 100 kilometers. All right, so I'll get you to try this one. So pause the video and try this one out. Lay's value size of chips is $5.99 for 415 grams. The regular size bag is $3.50 for 235 grams. Which is the better buy? Ugh. Give the price for 100 grams of chips. So see if you can figure that out, and then unpause and see me do this. All right, so we want the price per 100 grams. So we're going to start with price per gram. And to do price per gram, we do price divided by grams. And that'll be how many dollars for 1 gram of chips. And then if we times that answer by 100, we'll get the price per 100 grams of chips. And I get $1.44 per 100 grams. And then the regular size, again, dollars price per gram. If you do dollars divided by grams, times that by 100, you'll get the price of 100 grams instead of just 1 gram. And there we go, $1.48 for 100 grams. Which one's the better buy? Well, the value size is a bit cheaper for 100 grams. So per unit, it's a bit cheaper than the regular size bag of chips. So that's how you would do that calculation. And usually in a grocery store, you never actually have to pull out a calculator and do these calculations. So I'll give you this challenge next time you're in a grocery store. The value size bag of chips would say $5.99 in big numbers right there. But down in that bottom right corner of the price tags on the shelves, they will say $1.40 per 100 grams. And that gives you a unit rate that you can compare to the other. So look in the bottom right corner of price tags, you will see unit rates there in the grocery store. So if you're deciding which brand of ketchup is cheaper and they're different size bottles, you can look in that bottom right corner and they should have done the calculation for you. The only time you have to do the calculation yourself often if they put a sale tag price over top of this one, they won't recalculate the unit rate on the sale price, so you have to do it yourself if you're interested in seeing if it's actually cheaper. If the small bag of chips is on sale, sometimes it's not actually any cheaper than getting the big bag of chips, for instance. So I usually check those myself. And things like toilet paper and Kleenex is very difficult to figure out which one's the unit, because sometimes they'll give you the price of one roll versus the price of one Kleenex in the box. So sometimes they don't give you the same unit rate on those tags. Those ones are a bit trickier to figure out in real life. But this is the type of calculation you need to do for my class. Either do price divided by amount for the bananas, or do price divided by amount times 100 if you need a small unit like that. So what is a unit rate? How do you calculate it? It's usually the cost of each item is the unit rate, and it's usually done cost divided by the amount of items, or the amount of stuff that you're buying is usually the best way to calculate it. If you're dealing with a small unit like milliliters or grams, they don't often say the price per gram or the price per milliliter. They give you a price for 100 instead. How would you do that? Well, basically you just do cost divided by amount. Oh my god. And then times 100. All right, so cost divided by amount times 100. So if it was $1.25 for 300 milliliters, I would do $1.25 divide by 300 and then times by 100. And that's about 41 cents, 42 cents if I round that off, per 100 milliliters of whatever that product is. Okay, so the question that you're going to send me your answer to is, tell me which one's the better buy. Are you better off buying Costco brand of Pepsi, the 18-pack, or the 12-pack at Walmart? So you tell me which one's the better price, and then there's some additional practice after that that you can look at. 8 questions there, and I do have answers to all 8 of those at the bottom you can check your work on. But send me a picture of your answer for the Costco one, the Pepsi one there.